Today's GFG problem of the day, find the longest string. This is pretty easy problem. You have been given a strings array and this array contains strings. Yeah. So basically, yeah, this is the array of strings. You have given a longest string which is lexicographically. You have to find the longest string such that it is lexicographically smallest and its all of prefix are already present in the array. Example, this ABC, this is longest and its prefix are also present in the array, like A is present, AB is present, and ABC itself is present. So as you can see, length is 3, which is the longest, and is substring. There are two strings having the length 3, but still ABC is good, ABD is not, because the the prefix of ABC exists and ABD does not. In this case, if you can see, there is a string called ABDAB. Why it is the longest? Obviously this is the length 5, that's why this is the longest. And why it's a valid? Because it has all this prefix occurs in this string array, like A occurs, AB occurs, ABD occurs, ABDB, ABDB, ABDA, sorry, ABDA occurs, yeah. And the itself it is occurring, so the last prefix is just completely string. So that's what you need to do. This is pretty straightforward question. Let me just again write the code. Basically simple. You have to do sorting based on the length, such that the longest length come first, something like that. So sort your words dot array, words dot begin, words dot end. I'm sorting. I'm using a lambda function, string A, string B, such that return. If the both the size are same, then you have to do something, right? You have to see lexicographically order, then you have to see A should be less than B, otherwise size should be decreasing order, like A dot size is greater than B dot size. The longer size should come first, that's what I want, and lexicographically smallest should come first, that's what I want. Now we can say we have sorted this in a good order. Now just iterate over this array, auto x in this w, take out the string and see all its possible prefix. How its possible prefix you will get, select x dot size I plus plus. Now basically what you can do, int z is basically counting how many prefix are good prefix occurring in the substring. So how you calculate the prefix? First you will generate the prefix as string x is equal to not s. I used, let's use s, yeah, x dot substring 0 and length is I, and length can go up till 0. Length doesn't make any sense. Length can go up to 1 till the complete length, and you'll just check if u dot count exists for this string. You'll say z plus plus, otherwise you can just say breakout, and over here you can check if your z is equal to x dot size. You can just return this x string. As soon as you found a string, you will return it. If you doesn't found any of the string to satisfy the condition, if the none of the two length string satisfy a condition, one length set string is always satisfying the condition, because its length is one and prefix is also there. But there might be case when this one length is doesn't even exist, right? So for that matter, you just need to return this empty string at the end. Let how I do it. And before that, I want to make an unordered set for checking whether this is present or not. Okay? And why unordered set? Because for least time complexity, u and w dot begin to w dot end, it will have all the words and you just need to check them. You don't need any order. You don't need to, you just need to check count s whether it's present or not. If it's present, z plus plus, the prefix is present, and all the prefix are present, then you just return x. Let's start some of this up. Straightforward question, right? Sorting was just a thing, and okay, w. The only thing was this custom sorting based on the first decreasing size and then lexicographically order. Then you just need to check, this is just checking part, whether all the prefix, how you will check all the prefix from going fill s dot substr 0 select all the lengths, and if all are good, z plus plus will equal to x dot size, and then you will return x, and otherwise you will return empty string. That's about it. Let's move to the GFG problem of the yesterday's GFG problem. Maximum profit by choosing subset of interval. This is amazing question. Okay, wait a second. Okay, no, basically this is an amazing problem. Like given a list of n intervals, you have been given basically ith element as SEP, which denotes the starting point, ending point, and profit earned by this interval. Find the maximum profit one can achieve by choosing a subset of non-overlapping intervals. So that's why, if you saw like the previous video which we did of the lead code question, that was also a non-overlapping interval. Basically, it was based on the overlapping intervals. Here you have to see non-overlapping intervals, and you have to return like maximum profit that you can choose by achieve by choosing the non-overlapping intervals. So like in this case, uh, वैसे तो they have explained the test case, but let me show you like what they are saying. You have these intervals, right? 124, 157, and 244. How many of them are overlapping? 1 and 2 and 1 and 5 are obviously overlapping. 1 and 5 and 2 and 4 are overlapping, but these two are non-overlapping. 1 4 and 2 4. Now how you can choose the profit? Basically, profit can be added up for non-overlapping intervals. So the non-overlapping intervals, okay. So basically, you can either choose this interval 124 and 244 because these are non-overlapping. As you can see, 124 and ending at 2, starting at 2, going to 4. This is non-overlapping, right? So answer for this would be 4 plus 4, which is 8. Otherwise, what you could have choose just this 1 to 5 and 7, but this profit is not maximum. This is giving profit equal to 7. That's why it's just a temporary answer. The final answer is 8, right? So that's what you need to see. You need to see overlapping intervals. That how you can see. Oh, okay. First of all, you will just sort them based on the normal their starting time, I guess, right? Okay, why it's coming in the next line? Okay, I think. So first of all, you'll sort them on the starting time. So 125, 157, and 244. I think this is a good, good sorting order. Yeah, that's about it. It's a good sorting order. Now you will see from the first element, 1 to 4. You can say, okay, you can always take the first element. So your profit is currently equal to 4. Now you can say, I can only take elements which are after this 2. So you have to, go in this array and say, hey, is your starting point greater than 2 or not? No, it's not. He is your starting point greater than or equal to 2? Yes, it is. So you will take after this point, you will take this and you will do profit is equal to 8. These two things can come together because this starting point of this is basically less than or equal to ending point of this, not less than, greater than or equal to, yeah. And then 1 comma 5, then this the answer for this is equal to 8. Then you can choose to start at this point, right? 1 comma 5 comma 7. If you choose to start at this point, you can just say, okay, there's nothing I can add more because 1 to 5 is the ending point. I cannot take 2 because starting point is 2. It has to be, it is smaller than 5. So that's what we need to do. First of all, we'll sort this. Let's make it I dot n. And I don't think you just need to do anything else, but if you want, then you can just sort it based on the starting time. Yeah, that's what I'm doing. So I think that should be fine. Now I just want to calculate my solution, because that's basically, it depends on your starting index. So as your starting index change, the answer will change. For this starting index, the answer is 8. For this, the answer is just 7. For this, if you start at this point, you just cannot take anything else beyond that. So that's why the answer for this would be 4. So return solution of starting index and starting at 0. I'm passing it I vector, and I think that's all what I need, right? Now this is a basically kind of a DP question. Why? Because you have to just see whether you can take this or not. The take or not take DP question, like 1 to 4, you just cannot take this. But even if you can take this 2 4, let's say if it was 2 to let's say a9, right? 2 to 9 4, you can take this. But if you take this, you cannot take this, like let's say 3 to 6 on giving you profit very high 12, right? If you take 1 comma 2 comma 4, okay, you cannot take this. You can take this and your profit will be 8. Now you are standing at ninth position. You cannot take this 3 comma 6. Otherwise, if you have just skipped this part, can you take this 3? Yes, I can take this. If you take this, your profit will be 12 plus 4, which is 16. I think this would be the maximum answer for this case, right? Hmm. So this is basically DP question. You have to try choosing all possible options that you can choose. So it solve, int id, and I'm passing it the vector of interval. Now after this you have to say if your id is greater than equal to n, means there is nothing to choose, so you just return 0, not pick any element. Now there are two cases: int not take, when you just not take solve of id plus 1, and you will just move to this, you just move to id plus 1, you will not increment anything because you are not taking this particular thing, right? Otherwise else, not else, basically you have to calculate, what is the next point which you can take, I think. Yeah. So if you are not taking the next point, you are starting at id. If you are not taking this calculating this next point, one thing is just you can move to this, or you can find out what is the next point that I can take after this. I'm taking this. If you take this, you have to find what is the next point you take after this, because if you're not taking this 1 to 4, you are not worried about anything, you can just start at 1 comma 5 comma 7. But if you took this 1 comma 2 comma 4, you cannot start at 1 comma 5 comma 7, you cannot go to the next index just like as it is, because this 1 is lesser than this 2, you have to go something like which is greater than or equal to 2, right? You cannot go to this. So if you have taken this, you have to find, now I'm saying that I have taken this, so you have to find some index, the next index which you can take after taking this index id. So there is another function for find. So let's say find, I just need to pass a value. What is this value? This value is the ending point of this current element. I of id comma 1 represent the ending point of this, and I, you have to choose any index in this I vector where the starting point is greater than this ending point or equal to, can so be also. So now else you can say, like, not else, but you can say if int take is equal to, let's say, if you are taking this for sure, then you are moving to f of id, right? If you are moving to f of id, you are incrementing your value from, not v, I'm just, this is I, this is ID, and this is 2. The profit is present at the second index, 0, 1, 2. Yeah. And you are moving to something like you're calling solution of ID, not FID, F of ID. You're calling it this F of ID is your good next index that you can move to, and I, and then you can say return max of take, comma not take. Take this or you don't want to take this. And when this solve of f of it doesn't even exist, you will just return 0 from there, right? Because you cannot take anything after this, right? Okay, let's make our find function. We give just index, so it's just find. You're passing it value, passing it, or you can say you're passing it, ending point of one thing, and you want a starting point which is greater than this ending point or equal to is also working. So you'll say I'll start from id is equal to 0, and I'll say while my current element which is I comma id is the starting point is greater than or equal to this ending point. I'll, okay, this is good, this is not good. If it is less than this ending point, you have to do I plus plus, you cannot take this, and then you can just return your id. I think that's about it. Now you can apply dp, otherwise it will give TLE, as you can try to sum this up. Yeah, because for every option you cannot take two options, so the 2 key power n is obviously not going to be answer, but index is unique, so you can apply dp over the index, and index is 10 key power 4, right? And mem set you can do over here, mem set dp with -1, set your dp table with initially with -1, and then check if particular element, if what is this n is I dot size. If your dp of id is not equal to -1, you can just return your dp of id, whatever is present at that dp table. Otherwise you can make your dp id is equal to this, dp of id is equal to your the answer max, comma this, comma this. Now let's try to sum this up. Simple question it was. You just need to figure out that it's somehow a linear DP. But before that, it is, you have to take non-overlapping intervals. How you can take this? This is ID. Basically increment your the pointer, find the next index which you can take after taking this index. So basically there are two things, like not take or take. Yeah, that's about it, like the normal DB question. And you didn't, what is this problem? I think this is an extra. Hmm. What is the issue, man? Let's try to solve this around the index starting point. Vector int A, vector int B. Let's say return A of 0 and less than B of 0. What is happening, man? Oh, sorry. ID over here should be constrained on ID. ID should be less than n, and n is basically I dot size. You cannot just go on. You have to bound this. It should not go out of the bound. F of ID. Yeah. Now it's fine, I think. Okay, it's successfully passed. As you can see, the basic logic for this problem was, this only. First, you have to realize that, okay, how I can take intervals. If I took one interval, I can take only the next interval. For example, if you take 1 comma 4, you cannot take anything else, because otherwise the 2 the starting point is less than this. So you can take this 2 comma 3. Only you can take this, and you cannot even take this. So you have to say, like, you have to choose a DP. Basically, you have to try all possibilities. What if I choose 1 comma 4? Okay, then I cannot choose this, so answer is 4. What if I choose 2 comma 3 at first? You're not choosing this, you're skipping this, you're not taking this, and you're just moving at the next index. Like how we do it, solve of ID plus 1 comma I. So 2 comma 3, you can say, okay, I'm picking this up. What is the next index which I can take? Okay, that doesn't exist, because it should have starting point greater than 3. So f of id will come out as n, or you can say I dot size, and you will just return, you will just add this profit 7 and go on the index which is out of the bound, and it will return 0. That's what your answer is. So 7 is your answer, and dpid, and then you can also try to move to the next index, like 2 3 4. This will also give answer something like 4. A maximum of them would be 7, and that's what basically dp is helping us just to reduce the states, like how we reduce states from 2 power n to something like n over here, because this is just 1 ddp. Find function is very simple. You just need to see which next element which I can take, which has, uh starting point lesser than sorry, greater than or equal to this previous ending point, and that's about it. The sorting, I think, was not that issue, what I thought of. Let's try to remove the sorting. Let's actually try to sum this up. As you can see, it's perfectly submitted, because yeah, sorting is basically is based on the first, your starting index. That's about it. Okay guys, bye.